Hey everybody, Mr. Quick here. Today we're going to be looking at Eureka Math / Engage New York Math, Module 5, Lesson 3, the area of acute triangles. Not a cute triangle, although they're, I'm sure, quite adorable, but acute triangles. So, let's first of all do a quick review and look at what an acute triangle is. We remember that a triangle that looks like this, that has a 90-degree angle, or a right angle, is considered a right triangle. An acute triangle would be, well, let me change color so we can see this a little easier. This angle is less than 90 degrees, right? Because 90 degrees would look like that. This angle is less than 90 degrees because 90 degrees would look like that. And then finally our third angle is less than 90 degrees because 90 degrees would look like that. So we have three angles, none of which are 90 degrees or bigger. They're all acute angles, meaning they're smaller than 90 degrees. And so we have an acute triangle. Now, when you're trying to find the area of an acute triangle, here's the catch. You have to find the height. And the height of a triangle is not necessarily always one of its sides. The height, which is also called the altitude, is a line segment that goes from a vertex of the triangle and perpendicular to the opposite side. So, in other words, we're going to essentially create two right triangles. So we're going to start here from the vertex, which is where the two meet, the two corners meet, and we could do any vertex, but we're going to obviously do the one that is the easiest for us to draw here. We're going to draw a line right down the middle, and that's not perfect, but it's my iPad drawing. You get the idea. I don't have a ruler on this. And so if this is a 90-degree angle, and this is a 90-degree angle, essentially, now we have a right triangle here, and a right triangle here, and we know to find the area of a right triangle, we have area equals 1/2 base times height. And so we can just essentially do that twice to find the answer. Now, I'm going to show you a quick example doing it this way, and then I'm going to show you another way to do it, which I think you'll find even a little bit easier, but I want you to see the connection there. Okay, so we have our acute triangle. Each of our angles is less than 90 degrees. This one's probably pretty close to 90, but we're going to go with less, right? And so we're going to create our height, right? So we're going to go in from the vertex where the two meet all the way down to the base. This is now a 90-degree angle. We're going to say that this is 3 inches tall. We're going to say that from here to here we have 5 inches. And we're going to say from here to here we have 1.5 inches. Now, if I was to say area equals 1/2 base times height, I wanted to do this triangle first. We have 1/2 base times height, right? And so I'll do 5 times 3 first, which is 15. 1/2 times 15 would give me 7.5. That's just for this part of the triangle. Over here, we'd have 1/2. The base is 1 1/2, or 1.5. And then the height is still 3 inches, right? The height would be the same for both. So I'm going to say 1.5 times 3 is going to give me 4.5. 1/2, 4.5, or 1/2 times 4.5 is 2.25. So now I need to combine both halves of the triangle, 7.5 and 2.25. So I'm going to add them together, and we're going to end up with 9.75 inches squared for our area. So again, essentially we took this acute triangle and split it into two, count them, two right triangles. Now, there is another way to do this, and I'm going to show you that right now. Okay, same triangle. But this time we're going to look at area equals 1/2 base times height, and we're going to see if we can just combine this all together to see if we get the same answer that we had before, which was 9.75 inches squared. So if my base is 5 and 1.5, that would be 6.5 for my total base. So all the way across, right? So I have 1/2 times 6.5 times my height, which is 3. Okay. 3 times 6.5, I know 3 times 6 is 18. 3 times 0.5, which is 1/2, would be 1.5. So we end up with 19.5. 1/2 times 19.5 is going to give us 9.75. And how I figure that out is I know half of 18 is 9. Oops, sorry. And then to get from 18 to 19.5, you have 1.5. So half of that is 0.75. So area would be 9.75 inches. Gosh, I can't write today. Inches squared. So it's the exact same answer. So you can take the entire base times the height when you have an acute triangle, multiply those 1/2 base times height, and you're going to get the answer. So you don't have to do it as two separate right triangles, but you do have to know that when you have an acute triangle, that to get the height, you have to essentially create that that perpendicular line to give yourself two right angles. So let's look at this here. Okay, let's say this is our next acute triangle. So we know area equals 1/2 base times height. We can combine both halves, or not quite a half, I guess, but both parts of that triangle to give our new base. So 34 plus 12 is going to be 46. So we end up with area equals 1/2 times 46 times the height, which is 32. 1/2 of 46 would be 23. So we end up with area equals 23 times 32. And that's going to give us 736 meters squared. Okay, so I hope you're seeing that just like our right triangles, we can do area equals 1/2 base times height. The only difference here is you have to know where to get the height, right? It's not one of the lengths of one of the sides. It's creating those two right triangles and going from there. Okay, so if you have any questions, we'll go ahead and look at those or talk about those in class. We'll go through some more examples, and we'll show how it doesn't really matter which way the triangle goes, whether you flip it around, flip it on its side, flip it upside down. You still want to create those two right triangles and then do area equals 1/2 base times height. All right, thank you for watching, and we'll talk to you soon.